fleeting time it takes to watch this program, a biological tragedy is playing out on your kitchen counter. A single head of cabbage, severed from its roots, is beginning to die. It fights a losing, desperate battle against the invisible forces of oxidation, rampant enzymatic activity, and fluctuating ambient temperatures. The moment you cut into it with a standard kitchen knife, you are essentially committing culinary manslaughter. The dull blade crushes the cellular walls rather than severing them, bruising the plant tissue and inviting the rapid browning that turns a crisp salad into a limp, unappetizing mess within hours. But here, inside the sterile, hermetically sealed expanse of this monolithic processing facility, the fundamental rules of biological decay are suspended. This plant is a cathedral of high-volume preservation, ingesting 100,000 pounds of raw biomass every single day, roughly the takeoff weight of a fully loaded Boeing 737. It transforms this chaotic agricultural harvest into a product that defies nature, coleslaw that stays crisp, vibrant green, and biologically stable for 14 days. The secret isn't a bath of chemical preservatives. It is a specific, violent law of physics applied at 4,000 revolutions per minute. This is a war waged against inertia, friction, and the microscopic enemies hiding between the leaves. It is a symphony of stainless steel and chlorophyll, executed with military precision. This is the hypnotic shredding of modern coleslaw production. The operation begins at the loading dock, the chaotic event horizon where raw agriculture meets the rigid discipline of heavy industry. The raw material arrives from the field in high-density polyethylene bins, Mac X containers, capable of holding over 1,000 pounds of dense produce. At this stage, the product is critically vulnerable. It is heavy, irregular, and packed under its own crushing weight. The primary logistical enemy here is inertia, the tendency of a half-ton of vegetable matter to resist movement, and then, once moving, to destroy itself through kinetic impact. To move this much mass without pulverizing the bottom layer of vegetables requires a delicate touch applied with tremendous hydraulic force. The facility utilizes a bank of automated bin tippers, mechanical giants known as the gatekeepers. These aren't simple dump trucks emptying a load of gravel. The hydraulic pistons engage with a low-frequency, visceral groan, lifting the half-ton payload with a smooth, computerized arc. The tipping geometry is calculated to create a cascading waterfall rather than a damaging sheer drop. If the angle is too steep, the cabbage plummets and bruises, triggering the immediate release of polyphenol oxidase, the enzyme responsible for browning, before the process even begins. If the angle is too shallow, the production line starves, creating gaps that ripple down the entire factory floor. As the green avalanche hits the intake hopper, it enters the strict jurisdiction of the Quality Assurance Lab. Before a single leaf is permitted to enter the sterile processing zone, a random sample is pulled for a critical Brix test. A technician treats the vegetable like a geological specimen, drilling a core sample to measure the soluble solid content. They are hunting for sugar levels and specific density metrics. A head that is too airy will shatter like glass in the high-speed slicers. A head that is too dense might jam the coring blades, stripping gears and halting the line. Only produce that falls within a strict density deviation is cleared for the next stage. Once cleared, the raw heads travel up a steep, cleated incline conveyor. This is the singulation phase. Massive vibratory shakers oscillate the belt, using calculated friction to separate the tangled chaotic pile into an organized, single-file procession. They are marching toward their first major surgical intervention. A head of cabbage is an engineering paradox. The leaves are delicate, sweet, and desirable, but they are anchored to a central core that is wood-hard, bitter, and structurally inedible. This core is the spine of the plant, but for the purpose of coleslaw, it is a contaminant. In the past, removing this core was an ergonomic nightmare, a manual task requiring a curved knife and a dangerous amount of repetitive wrist torque. executed thousands of times per shift by fatigued workers. Today, that risk is eliminated by the Magnuson auger system, a machine that brings robotic consistency to organic irregularity. This unit performs what can only be described as industrial neurosurgery. The Cabbage enters a V-shaped flighted conveyor, which uses gravity to mechanically center the vegetable. However, nature is rarely perfectly symmetrical. To compensate for the lopsided growth of field crops, advanced optical sensors scan the approaching topography of each head. The system calculates the geometric center versus the visual center in microseconds, adjusting the target coordinates on the fly. Once locked in position, the machine engages the hold-down assembly. Padded pneumatic clamps descend to immobilize the vegetable, pinning it with just enough force to hold it steady without bruising the outer leaves. Then the executioner arrives. A custom-milled stainless steel auger, driven by a pneumatic ram operating at 80 psi, plunges vertically into the heart of the plant. This is a Z-axis vector strike. The auger doesn't just cut, it grinds. The drill bit is designed with a specific aggressive thread pitch that pulverizes the fibrous stem while simultaneously pulling the debris upward and out of the cavity. Much like a wood drill clears sawdust, precision here is measured in millimeters. If the sensors miscalculate by even half an inch, the drill destroys the prime inner leaves, the heart of the slaw. If the drill depth is too shallow, the bitter root remains, ruining the flavor profile. It is a precise lobotomy executed at a blistering rate of 60 heads per minute per lane. The pulverized core drops through a trapdoor. The result is a torus, a donut-shaped biological structure. The bitter skeleton has been extracted, leaving only the sweet, usable biomass. The pulverized cores are ejected onto a secondary waste conveyor. In a closed-loop sustainability effort, this organic shrapnel is not discarded into a landfill. It is routed to a separate hopper to be converted into nutrient-rich cattle feed. Nothing is wasted. The hollowed heads, now structurally compromised but fully edible, advance to the most violent stage of the operation. We now approach the violent heart of the facility, the Urschel Translicer 2510. If the previous machine was a careful surgeon, this one is a jet engine mounted in a kitchen. The challenge of slicing cabbage for premium coleslaw is maintaining cellular integrity. A dull or slow blade acts like a hammer. It crushes the plant cells, causing them to burst and leak vital fluids. This cellular trauma is exactly what makes homemade slaw turn soggy, gray, and brown within a day. To keep the product crisp for weeks, you cannot chop it. You must shear it at a velocity so high that the cell walls don't have time to react or compress. The Translicer operates on a principle of centrifugal acceleration. The hollowed cabbage heads are dropped onto high-velocity feed belts that sprint them toward the cutting zone. They are literally fired into the maw of a 25-inch stainless steel wheel spinning at a terrifying 4,000 revolutions per minute. The wheel is a blur of kinetic energy, fitted with razor-sharp microblades, angled to a tolerance of less than a millimeter. When the cabbage impacts this spinning shield, it doesn't just break apart. It is vaporized into uniform, 1/8-inch ribbons in less than 0.2 seconds. The human eye can't track the transformation. One moment, it is a solid vegetable. The next, it is a cloud. The physics here are critical to the final taste. The machine utilizes a sliding shear action. Imagine the difference between slicing a tomato with a razor blade versus smashing it with a baseball bat. The extreme peripheral speed of the wheel ensures that the blade passes through the leaf before the leaf can flex or compress. The cut is cleaner than a scalpel's incision. This preserves the microscopic cell structure, locking the moisture inside the shred rather than bleeding it out onto the conveyor belt. The sensory experience in this zone is overwhelming. The sound is a terrifying high-pitched whine, similar to a turbine spooling up for takeoff. The visual is a continuous explosion of green confetti. The operators monitor the temperature of the cutting wheel constantly using thermal cameras. If the wheel creates friction heat, the edges of the lettuce will cauterize and brown, ruining the batch. It is a thermodynamic balancing act, maintaining a cool surgical slice amidst extreme mechanical violence. The chaotic pile of shreds now drops onto a vibrating shaker table. The vibration settles the pile and spreads it out, preparing it for a journey that will simulate a Class 5 Rapid. The product is now in its shredded state, but it carries the invisible baggage of the open field. Microscopic grit, sand, and potential biological contaminants hiding in the deep crevices of the leaves. Standard pressure washing is too aggressive. It would destroy the delicate ribbons we just created. The solution is the chromium helical washer, essentially a jacuzzi gauntlet designed for vegetables. The cabbage plunges into a chilled flume tank containing thousands of gallons of sanitizing solution. Here, the facility employs helical flow dynamics. Water jets positioned at specific angles along the tank walls create a corkscrew current. This forces every individual shred of cabbage to swim a specific elongated path through the water, ensuring maximum contact time with the cleaning agents. It prevents clumping, ensuring that no leaf hides behind another. But the water flow alone isn't enough to dislodge the stubborn grit. The machine utilizes a subsurface aeration system to agitate the mix. Injectors at the bottom of the tank fire compressed air into the stream, creating a roiling boil effect. These bubbles act as pneumatic scrubbers. As they rise and burst against the cabbage, they create microturbulence that gently vibrates the dirt off the leaf surface without applying mechanical pressure. It is a scrubbing action derived entirely from air and water physics, gentle enough for a flower petal, but effective enough for a root vegetable. The heavy sediments, sand, and rocks lose their battle with gravity and fall through a trap at the bottom of the tank, known as the sediment trap. The buoyant cabbage floats over the top, carried by the current. The water temperature is kept just above freezing, around 34 degrees Fahrenheit. This shocks the vegetable tissues, causing the cell walls to contract and firm up, adding that signature crunch to the final bite. The decontamination is complete, but now we have a new enemy. The product is saturated. Wet coleslaw creates a runny dressing and accelerates bacterial growth. We need to dry a fragile leaf that is 90% water without using heat. Heat drying would cook the cabbage. Air blowing is too slow for this volume. The only way to remove surface moisture while keeping the internal moisture intact is brute force gravity. The saturated shreds are loaded into the JBT continuous centrifuge. This is the same physical principle used in astronaut G-force training, scaled down for salad production. The drum begins to rotate. It doesn't just spin, it accelerates rapidly to create a centrifugal force of nearly 1,000 Gs. At this magnitude, water molecules can no longer cling to the surface of the leaf. The adhesion forces, the bond between water and vegetable, are shattered. The water is physically ripped away, exiting through the perforated walls of the drum like a radial sprinkler system, channeling into drains below. Or CGI. The cabbage is pinned flat against the wall. Inside the drum, the cabbage is pinned against the steel wall with crushing force. This pressure has a secondary benefit. It crisps the texture by compressing the fiber. However, the timing is a razor's edge. Spin it too long, and you crush the cellular structure, creating a mushy product. Spin it too short, and you leave water pockets that will dilute the mayonnaise in the final package. The cycle is automated by sensitive load sensors that detect the shift in weight as the water exits. When the dry weight in the target is hit, the brake engages. The drum decelerates, and the cabbage, now dry to the touch, but hydrated internally, tumbles out onto the inspection belt. We are near the end of the line, but the standards for acceptance tighten significantly. In a stream of millions of green shreds, a single defect, a piece of wood, a fragment of hard plastic, or a brown leaf is unacceptable. The human eye cannot process moving objects at this speed, Fatigue sets in within minutes. To guarantee purity, the facility deploys the Tomra Sentinel-2, an optical sorting system that functions like an anti-missile defense grid. The conveyor belt ends, launching the Cabbage into a free-fall trajectory. For a fraction of a second, the product is airborne. In this flight path, it passes through a barrage of high-intensity laser scanners and multispectral cameras. These sensors aren't just looking at color. They are analyzing the chlorophyll signature and density of every flying particle. They scan 20,000 objects per second. The system's logic board builds a real-time map of the falling stream, distinguishing between a healthy cabbage shred and a foreign object based on how it refracts light. When the computer identifies a foreigner, perhaps a leaf tip that is slightly necrotic or a piece of core that slipped through the auger, it calculates the object's trajectory and a firing solution. A bank of high-speed air ejectors, positioned millimeters away, fires a precise bullet of compressed air. Pop. The defect is sniped out of midair, blasted into a reject chute, while the good product continues its vertical fall undisturbed. It is a digital gatekeeper that ensures 99.9% purity, operating faster than human reflexes could ever hope to match. The slaw is now clean, dry, crisp, and pure, but it is still breathing. Like all plants, cabbage consumes oxygen and releases carbon dioxide. If you seal it in a bag with normal air, it will suffocate, sour, and spoil within days. To cheat time, the packaging line employs modified atmosphere packaging, or MEEP. As the finished units are weighed and dropped into their packaging film, a gas flush system intervenes. A nozzle injects a precise cocktail of gases, typically a blend high in nitrogen and low in oxygen, into the bag just milliseconds before the heat seal jaws clamp shut. This artificial atmosphere puts the vegetable into a state of suspended animation. By displacing the oxygen, the respiration rate of the leaf slows to a crawl. The oxidation clock is paused. It is effectively cryosleep for salad. The bags are sealed, labeled, and pass through a final metal detector, the last line of defense against ferrous contaminants. Robotic palletizers stack the cases with geometric efficiency, building towers of salad ready for cold storage. From the moment the raw bin was tipped to this final seal, only 45 minutes have elapsed. The product is now ready to ship to supermarkets and restaurants nationwide, locked in freshness. The Urschel Translikers clean cut kept the cells intact. The centrifuge stripped the moisture without heat, and the nitrogen flush bought us time. The result is a simple side dish that requires a staggering amount of industrial violence to create. It is a crunchy, consistent engineering marvel, shredded to perfection.